So I want us to proceed with this lesson. You had seen my previous lesson on cells and simple circuit. I want us to move on with it. I want us to see the main sources of electricity, and to be specific, we are going to look at the chemical cells. Generators and solar cells are sources, but we are not seeing it at this particular topic. We shall discuss it later on when we are taking our discussion into other levels. So, chemical cells are categorized into two. We have primary chemical cells and secondary chemical cells, depending on how they function. Those that can be recharged after the chemicals are used, it can be recharged, are secondary. The ones that when they are over, you use it to chase parts from the field, to those are the primary. They include the dry cells. So to be specific to you, we are going to see five chemical cells. Three of them are primary and two of them are secondary. So starting with primary cells, there are cells that cannot be recharged for use again. For example, a simple dry cell. When they are over, you use it to chase stones from eating the millet in the farm, or you use it to chase dogs away from the home state. Dogs which do not belong to your home, you chase it away. Or sometimes when you run away and your mom wants to beat you, she will use that dry cell because it's over to throw it into your head. Now, we are starting with a simple cell. The diagram you are seeing here, this one is a simple cell. It was the first of all the cells. It had a lot of problems. It was not sustainable. It could not run for a long time. So this simple cell, it had a container. It had a container. Inside the container, we had dilute sulfuric acid. I said in my previous video that a substance in liquid state or in aqueous state that can allow current to pass through it, we call that particular substance an electrolyte. We call it an electrolyte. So one of the conductors that dips into the liquid, we call it the electrode. So we have copper electrode and we have the zinc electrode. Copper and the zinc electrode. Don't worry why we put one to be copper and the other one to be zinc. Why not vice versa? As we are moving on, you will notice and you will get it clearly why one is copper and the other one is zinc. It is a match of chemistry, so you will know it as we are going on. Now, this is a cell which a bulb will light for a very short time and then it goes off. What provides the chemicals? The dilute sulfuric acid, which we are calling it the electrolyte. It had two problems. We are calling it the defects of a simple cell. It had polarization and local action. I'm using the word past tense because nowadays it's rare to be used. It has been improved. What we are going to see it next. Let's see what is polarization. It is the accumulation of bubbles around the copper plate, this copper plate here. After a very short period of time, a lot of bubbles accumulate. And when these bubbles accumulate, the bulb stops lighting. Why? Bubbles, whenever you see a bubble, it's a gas or it's air, if I may say so. And air, when I was mentioning the conductors of electricity, you didn't hear me talking of air because it is not. So when they accumulate around the copper plate, this part, then it means they are going to prevent current flowing. We call it in physics internal resistance. So polarization increases the internal resistance. The hindrance of the flow of current inside a cell or a petri, we call it the internal resistance. So polarization causes internal resistance, and it makes the bulb to go off, or to go off after a short period of time. Then the other defect is what we call local action. Local action is the depletion of the zinc electrode. The depletion of the zinc electrode. We call it again the eating away of zinc. When zinc reacts with sulfuric acid, then it gets depleted. It gets eaten by the acid. So we call it the local action. Those are the two problems a simple cell faces. Though there's a remedy for this, local action and polarization, we can say this. Local action, this gas, actually that accumulates at the copper plate is hydrogen gas. So if we can find how to remove that hydrogen gas, then we will have solved the problem of polarization. And we use what we call a polarizer. A depolarizer. And to be specific, potassium dichromate. So the oxygen from the depolarizer or from the potassium dichromate will do what? Will react with the hydrogen that had been accumulated at the copper at the copper plate, and therefore it will have been removed. Another very funny way that we can overcome polarization is removing it from the solution. You wipe it using a cloth, or you brush the bubbles off, then you return it. It's a very tiresome work. I prefer the first one because you just add the depolarizer inside the electrolyte, and as the process continues, what happens? Any hydrogen gas formed is immediately oxidized to water. Yes, that's why again, a dry cell after some time, it is wet. Why? The hydrogen produced was oxidized to water. What about local action? I've said local action is the eating away of zinc. How can we improve it? By using of a pure zinc. That's the main way, by using of a pure zinc. The other one is coating zinc with mercury. Coating zinc with mercury, famously known as amalgamation. That was a simple cell. Now, the improvement of a simple cell was what we call Leclanche cell. Leclanche cell. Leclanche cell. So you can see it. Those are the parts of a Leclanche cell. It has carbon rod and zinc rod. Then it has a mixture of carbon and manganese oxide. It has ammonium chloride jelly, and it has a porous spot. It also has a fent. Fent is a hole. Starting with fent, it allows the gas produced to escape. Yes. Zinc rod and carbon rod, those are the terminals of the cell. A mixture of carbon and manganese oxide, their role is for depolarization. Ammonium chloride jelly is the electrolyte. That is it. So I've explained to you that. Now again, we still have those two problems, that is the local action and polarization in this particular problem, but it is so much minimized. This cell, Leclanche cell, is used whereby small amount of current is required. But if large amount of current is required, then we will never advise you to use a Leclanche cell. Yes. So can you see the role of the carbon rod, the carbon powder, the manganese oxide, the local action? That is the Leclanche cell. Now, the improvement of Leclanche cell takes us to what we call the dry cell. This is now the last of the primary cells, the dry cell. The dry cell now is the one we always use in our radios, torches, calculators, even your stopwatch. Dry cells. There is one that my microphone is using, but it's very small. You cannot see it. You cannot actually see it. This is a dry cell. It can be used by calculators. My microphone is using it. So and many other small gadgets, they use dry cell. As long as not large amount of current is required, dry cell is the best. When it's over, you throw it away. So it has a metal case, seal insulator, carbon rod, zinc case. Zinc case acts as the negative terminal. Ammonium chloride paste or jelly, it acts as the electrolyte. We have about that carbon and manganese for oxide. So the same role these particular substances and parts were performing in Lake Langi, they would still continue with their role. So I've just displayed for you. You will go through it, you will read it. You just pause the video and read it, though we have explained. Now, those were the dry cells, the Lake Langi cell and the simple cell. Now, what is happening is, we look at the care and their uses, then we look at the secondary cells. We have two of them. How do we care for the dry cell? Large current should not be drawn from the dry cell within a short time. The terminals should not be shorted. What do we mean by the term the terminals should not be shorted? Do not connect positive and negative terminal using a wire. That is shorting. The cells must be stored in a dry place. That's a common sense. Uses of the dry cells. Where are they used? Yes, they are used in torches, calculators, and radios. So that one we have mentioned earlier. Now let's look at the secondary cells. They are rechargeable cells. They can also be known as storage cells. They can store electrical energy as chemical energy. Remember, chemical energy is the stored energy. You learned this in Science in Action class 7. Examples are the lead acid accumulator and the nickel alkaline accumulator. Actually, they are the same. What varies between the two is what is inside. That is what is the electrolyte. If the electrolyte is sulfuric 6 acid, then we will call it lead acid accumulator. If it is potassium hydroxide, which is a base, then it will be the nickel alkaline accumulator. Now, these are just a display of the same. Positive terminal here, negative terminal here. We have an ammeter here to measure the current in amperes. We have a voltmeter here to measure the voltage in volts. It is being now charged. When you see it connected to another high tension source, it is being charged. It is an lead acid accumulator. So it has a sulfuric 6 acid solution that acts as the electrolyte. The gaps, it has some gaps, have small holes to allow a gas that is mainly hydrogen and small portion of oxygen. So when this particular cell or accumulator is being recharged, the caps are left open to allow what? To allow hydrogen gas from to escape. Another thing that I have to tell you is this. You will be asked this question. Why is it that? Why is it that you are not supposed to smoke near a charging battery? I'm not advising anyone to smoke away from a charging battery, but it is advisable not to smoke near a charging battery, because hydrogen gas produced when a battery is being charged is flammable. It can catch fire easily. If the density of the acid becomes too low, the accumulator is said to be discharged, and you need to recharge it by putting more, by connecting it to a potential difference. It is charged by connecting a DC car as shown below it, this one that you have seen it. This is the most reliable, long-lasting, and cost-effective of the secondary cells. A 12 volts lead acid accumulator has 6 cells connected in series. Yes, now there is a small calculation I want to take you through. We call it the capacity of an accumulator. The capacity of an accumulator. I'm checking if okay, so the amount of current that can be drawn in a given time from the battery, it is expressed in ampere hours. Q in from our previous lesson, Q is equals to IT. I in amperes, T in seconds. You will get charge. Now, this is another thing that I want you to be very careful on. When you multiply current and time in hours, you will not get charge. You get a capacity. The formula is the same, I times time, but time is the one that determines what will happen here, or what you will get as your answer. If you use time in hours, you will get ampere hour. That is the capacity of the battery. If you use time in seconds, you will get charge in coulombs. Be careful. Look at this example here. A battery is rated 120 ampere hour. How long will it work if it steadily supplies a current of 4 amperes? How long? So we are looking for time. We are looking for time. So if the capacity is given by time, I mean current times time in hours. Now we are asking for time. It's going to be the capacity, which is 120 over 4. You get 30 hours, not seconds. Another example there, the current capacity of an accumulator is 40 ampere hour. Find the amount of current flowing if the accumulator is used for 600 minutes. So this means that we need to convert 600 minutes to hours by dividing by 60. We get 10 hours. 10 hours, and we are looking for current. 40 divided by 10, you get 4 amperes. Yes, so that was it. How do we maintain an accumulator? It is one of the most sensitive. A lead acid accumulator is one of the most sensitive that requires a lot of maintenance. I've projected for you the maintenance of the accumulator. The first one is the level of the electrolyte should be checked regularly and maintained above the plates. Topping should be done by distilled water, not acid. There are 2 points here I want you to get. We top it using distilled water. Not just water, distilled water. Why specifically distilled water? Because distilled water has no impurities. The accumulator should be charged when the EMF of the cell drops below 1.8 volts and when the relative density of the acid falls below 1.12. We measure relative density using hydrometer. Large currents should not be drawn from the battery for a long time. That one we have said. It also applies to the dry cells. Should not be left in a discharged condition for a long period, as sulfation, not wokofu, as sulfation may take place. What is sulfation? The lead may react with the acid. The lead metal may react with the acid. And remember, lead sulfate is insoluble. Okay. Shorting, overcharging of the accumulator should be avoided. Even in dry cells, it applies. Terminals should always be kept clean and greased, common sense. The accumulator should not be directly placed on the ground during storage. It should be rested on an insulator, like a wooden block or a box. Good, that was it. Now, that was lead acid. I mean accumulator that uses acid as the electrolyte. Now, let's look at alkaline accumulators. And the electrolyte in this case is alkaline solution, which is potassium hydroxide. And I have said it earlier. They include the nickel, cadmium, and nickel ion accumulators. The difference is it using cadmium or ion? Yes, and you can see it there. Potassium hydroxide being the electrolyte there. Now let's look at the advantages of this over the acid over the lead acid accumulator. What is the advantage that the nickel alkaline accumulators have over the lead acid accumulators? Large currents can be drawn from them over a short period of time, so they require little attention to maintain. They are lighter than lead acid accumulators, so you can walk with it around. They can be kept in a discharged condition for a very long time before sulfation or before the cells are ruined. But they are very expensive and they have a lower EMF per cell. Yes, but you see, the disadvantages are only two. The advantages are many. What is the difference between a primary cell and a secondary cell? But before that, where do we use accumulators? Accumulators in general, not just lead acid or nickel alkaline, accumulators. They're used in ships, hospitals, and buildings where large currents might be needed for emergency. Yes. Buildings, so that when you are on a lift and you are on the midway, being lifted up or being brought down, and the power goes off, we shall have large accumulators for emergency. These are the difference between the primary cells and the secondary cells. Primary cells cannot be recharged after use. Secondary cells are rechargeable. Small current can be drawn from them. Large current can be drawn from them. That's another difference. You only draw a small current from primary cells, but secondary cells you can draw a large amount of current. Now, these are the revision exercise. I will not read for you. You simply pause the video, you copy these questions, you do it. That is from question 1 to question 4. This side, it does up to question 8. These are just for you. You just pause the video and copy the questions. I believe they are feasible from your side. We are not done. So you just pause the video, copy the questions, and move on. It is working smart. We are not done. Yes, they are very nice questions. They are very nice questions. Please don't leave them. Another questions now. Just copy them as you have paused the video. Yes, up to question 23. I wish you all the best. May God bless you. Don't forget to share to any other student who want to learn physics. Thank you.